And I will invite Filipe, who came before, who is also the head of the lab manager of the Fab Lab in the Champalimaud Institute, and also responsible for the production site of the Aoife. So we can see how all of you three are connected through these great open tools that you created. Okay, I just put that. The guideline, but with the mic. Well, I think you did already a great job at answering most of these questions during your talk. But, well, one question perhaps to start the discussion is, I mean, it's obviously a successful story, what you did, and I guess some of the most accomplished initiative in terms of open hardware for neurophysiologists. And so how are you sustaining such, I mean, how did it go all along the process, and what's the future to sustain such initiative? I mean, you are both scientists, you will need to run labs, it takes a lot of time and some cost. And so what's the future of such initiative?
Yeah, so the way we did our project was we had the first microscope working after about 6 months. We then had our first full set of data for our first paper within about 8 months after that. And then I really invested a year after the point of having a fully functioning microscope in our lab to the point where we had a system that we could share. So there was really a year of my postdoc that was just invested in turning a tool that worked in our, and you know, when I was in the vicinity of being around it, to the tool we were ready to share. Once we shared it, I think part of the reason why our project and also OpenEFIS has been successful is that there is a decent amount of community engagement. So after we shared the Miniscope project, I'm sure at least half my time as a postdoc for the next year and a half was just answering emails and doing workshops and talking to people and making sure that when someone has a problem with soldering or the data is not showing up on the computer, that we try to solve that before they decide that it's a problem with our system and not with their setup. And that once a few people have an issue with the system in neuroscience, that word spreads very quickly, and it soon would become, oh, the Miniscope is no good. And so it really was a huge investment in that case. Now we're at a point where we're rethinking how to disseminate the newest tools. One is we would like to kind of centralize where all the components come from, so you don't have to deal with 5 companies, but also maybe provide things like Jakob mentioned, provide support that's not a postdoc that's sort of doing it on the side, but actually provide very useful support, and maybe labs pay for that, which in the end saves the lab a ton of time and a ton of money.
Okay, regarding the future of these projects, they need support. And probably I will say the forbidden word is money. So this kind of project needs 2 things to start. Is motivated people, I think we have, and also need smart people on the board of the institutes that can fund this kind of projects. And it's not all about money, of course, but money is essential here. And I will say that it's not crucial, but we should aim to have some support, not only on motivation, but only from some money to support. Because it not only support customers, it's also supporting the project. It's 2 supports that we need to think about it. And the customers also need someone always available. And supporting customers is also supporting the future of these tools.
Yeah, I think I couldn't agree more. It's really not a well-matched task for a postdoc or a starting PI to be a full-time support person for any project from a scheduling point of view, but also because that's just not what we're being evaluated for. That's basically not our job. And I think a big part of why OpenEFIS is working so well right now, and once we reach this critical mass that Danielle alluded to, where if you have enough users that can help each other, the burden for support goes down a little bit, but you still have the problem that you need to get the tool out. And at some point, no matter how you spin it and what technology you use, someone needs to put the thing in a box and ship it out and make sure that there's enough there. So OpenEFIS couldn't work really if it wasn't for Filipe organizing the commercial aspects of distributing things, right? So if you buy an open Aoife system now, you have it the next day in 2 days or something like that. Yeah, that's because you guys put in a lot of effort in setting up the system and keeping it running, which again has a cost associated with it, right? You need to pay salaries, you need to have a place to put stuff, keeping inventories, all that stuff. You can't really, or it's hard, you guys have done it fairly well, but it took your time, right? You can't really expect to have a project like this and then magically get it into people's hands, and because it's good, it will automatically work. You need to put a lot of effort into the distribution pipelines, and a lot of that starts to look like a commercial enterprise because it is in the end, right? You gotta get the tools out there somehow. I think there should be more public funding for such things because it pays for the science. I think it's a very good use of funding if you're measuring it by almost any metric of scientific success, and it doesn't exist yet. But I think it's a misunderstanding that we see a lot where everyone thinks that, oh, you just get a 3D printer and then you can make whatever you want. That's inefficient. And I think we need to see more diversity in how people get tools.
To follow up on that then, as you mentioned, so it sounds like, I mean, and I followed the process, you started with simple version where we could buy component by ourselves, assemble it in the lab and build the thing, and then your last version is so complex that we can't make it ourselves, so then we have to go through this shop that will sell the product, and so it looks like we closed the loop, and then we are back to somehow we'll be dependent on the system to a commercial. To buy it this way. So I mean, my question is how can you control that the price is not exploding anymore because your technology becomes unique, and then we are back to the beginning somehow. Although I know you have all the open source aspect that makes it more flexible.
It's a good question, right? It's true that the last systems, I think that goes for the next generation Miniscope as much as for our system, are definitely not in a realm that you can just build in your lab. I don't know how hard it is to make it's getting trickier as the electronics get smaller. It's not the kind of stuff you can solder yourself. There are more parts, yada yada. So it looks a little bit like a commercial system. The difference is that now it's a commercial looking system where everyone can download the tools, and with a little bit of time investment, you can make the PCBs in China for not that much money, or you can find some companies in the US that make it if you want to spend a little bit more money. So it's still something where if you try to raise the prices, you're immediately going to get crushed by other people that are selling it for less. So that's the one thing. The other thing is that by doing that and by having systems out in the open where people know what goes into it, it also puts pressure on companies to not overcharge. And we're starting to see that a little bit with even 2-photon microscopes, where in the beginning it was a monolithic thing that you bought for a boatload of money, and now there are, so I had a slide where I put INSS, which is Bruno Pichler and, I'm blanking on the other name. Anyways, it's a company out of London that makes 2-photon microscopes that is basically Dale Eager, I think, yes. Where they basically come to your lab and they build a 2-photon microscope for you. And that is starting to become possible across more domains where people really understand what goes into it. And that now means that if a commercial company wants to raise the prices again, the customers can say, well, these guys tell me that this part only costs $10,000. I see that in your pricing list you put $30,000 there. Is this a hidden service cost? Are you subsidizing someone that can come fix it for me later? Or are you pulling the wool over my eyes, right? So I think education for the scientists that are the customers also helps. It's a little bit like with the publishing market, right? Once you have transparency, then the market works better.
I think, so there's a bunch of different kind of needs for labs that there's a spectrum between sharing just something on GitHub versus having a commercial system can serve. So for the Miniscope so far, it's been that labs literally go and purchase each component from a company. I think going forward, there is this, you can do this cheap system even for our newest one where for a slight increase in cost, a single company can package all the components but not assemble any of it. And that has the added benefit that forces someone in the lab to know what's going on with the system and how to fix it. And it really, even for our new system, you might break some stuff initially, but I can assemble the new one in 10 minutes, right? So there are labs that have time available and don't have as much money, and so there's maybe that option. But then there's a ton of labs that would rather pay a little bit more and get just a working system out of the box. And I think we can serve all of that community across that spectrum, even to the point of labs that want additional service, incorporating that into some sort of service fee or whatever. I think can work in the whole aspect of open source.
Perhaps we can ask the audience if they have any question before we follow up on the discussion. Is there any question? Not that I can see. There is one there.
Yeah, thanks for working on these two great projects. I was wondering one thing. Daniel showed in his presentation that he's now going to implement EFIS, and that's something you've been doing for years. And both projects could benefit from Bonsai, for example, which you've been using. So is there a way to somehow combine all these, and we heard a few others here, all these cool open source projects, hardware, to have one, I don't know, site or platform that can help out different projects?
So I think the Miniscope project has been talking with OpenEFIS, and I think this could be a really great way to go, right? So I mean, we have the same goals in mind, which we are sort of scientists that are in it to do our own work and support the neuroscience community. And we actually are doing the same thing, right? Other than the recording modality, we do everything. Once you get off the animal's head, even to the cabling coming off the animal's head, we're doing identical things. All mostly in freely behaving animals and getting some sort of neural data. So that's sort of the conversation we've had, is how to sort of join together in the common aspects of our projects to develop something that's more than maybe the sum of its parts. I don't know.
Yeah, so John and Jack, who developed this next generation EFIS system, currently are using Bonsai to stream all the data of the system, simply because with all these different data sources that they put on the head stage, the only way to handle that gracefully, because they come at different sample rates and it's a complete mess. So currently Bonsai is actually the only system that supports visualizing and recording data of the new system. So that there might be a future in that as like a longer term perspective, yeah.
And,
I would like to say a simple thing, that collaboration is great, because we have, instead of one or two teams, we have more teams pushing this together I believe, in the right way. But I also believe that each project should keep their own independency. So they should not depend on the others. Otherwise, if something happens with, I don't know, Daniel wants to go to the industry and forgot everything about it, so there is a dependency that we should not have.
Well, actually, it was also my point, is like, what's the future? I mean, it's pretty good in your case example of like we already see the different project merging, and it was like the last point I wanted to address is like how would you see the future? I mean, if you have to imagine like beyond your own implication in this project, do you think it could be like a self-living on a platform, or it will be anyway like needs to be sustained by some institution or by a third party, like for example like a fab lab in an institution or in at least one place? It doesn't have to be in every country, but how do you see like the future of these kind of things? Or will it completely move to companies? Even if I understand your point that because it will be very competitive because everything is online, then they may like compete with each other and keep the price low. I mean, did you ever imagine like to go so far that in like 10 years, I mean, you may be somewhere else or doing something else? And how will your projects survive you somehow?
Yeah. I think probably all of our goals, at least partly, is to change the way novel technologies get disseminated and shared. So, like EFIS is a great example that 15 years ago, if you wanted to do EFIS in lab, you probably had to rely on a $50,000 rig to get like low noise, reasonable recordings. And now, like the OpenEFIS system outperforms what you can get commercially at a fraction of the price, right? And so there are definitely still technologies that are going to be expensive, that are going to be hundreds of thousands of dollars. But there are more and more of these technologies like the Miniscope and EFIS that don't have to be that expensive. And I think not relying on the standard model where you use public funds to develop a technology and then directly go to the commercial sector and raise prices by a factor of 10 or 100, I think our hope is that we can change that model a little bit and make an infrastructure in which there's transformative tools that are available to not just the top 5% of labs, but available to the vast majority of neuroscience labs. And I think we are all committed to doing that to begin with, but I think in the time that we're definitely around, we can, I think, have a big effect on pushing things in that direction.
Yeah, I think there's also a big challenge that all these projects face, that we're certainly facing, which is that of integrating more new people to keep the thing going, right? So this is part of where I think it's important to be really aggressive about pushing credit to the people that actually did the work, right? So the fact that I'm not currently doing any development on the system is not a problem because John and Jack are doing a lot of the hardware development. The fact that I'm not doing any software development, or the fact that Josh now has other duties at the Allen is not a problem because Josh now has a grant where he can hire 2 programmers for 5 years or something like that, right? So now it is all of our goal to integrate people like that into the system where they're getting credit, they're integrated into the tools, they bring their own expertise to it, but we're not starting completely fresh and reinventing the wheel every time, which is a fine balance, right? Because you don't want to put new people on a project and then tell them how things are done, because they're bringing better new ideas. So if we have to take apart some of the OpenEFIS software to make place for using the NeuroPixels probes, then that's good because that's the future, right? And we need to sort of go a couple of years at a time and always bring in new people on the development and support end. But I also think that there's definitely a need for sort of larger scale organizations that handle the distribution and setting standards, things like that, right? That maybe no individual person can do, and where it would be good to get funding for something like that. Or, like in your case, institutional funding for fabrication laboratories or something like that. So I think it's going to be a mosaic of different things, but the biggest challenge for us is definitely to get people interested and invested to then carry on the torch, so to speak.
And probably try to not depend that much on grants, because grants you will never know.
Is there some question from?
Yes. Super nice. Thank you very much for the presentations. Do you know of similar initiatives pointed to make available, accessible intracellular recordings? I mean, your work is clearly focused on in vivo, freely moving, and so on. But then at the same time, intracellular recordings are super popular. I mean, it's an approach that people have been using for a long time. And still, the equipment and even the acquisition systems are very expensive, right? Do you know of similar initiatives on that direction?
Well, Intan has a cheaper patch clamp acquisition hardware. It's cheaper than, the actual chip's pretty cheap. Their acquisition system is $7,000 or something, but theoretically it could be incorporated into some flexible acquisition systems that are cheap and designed in the future. We have like a kind of a random side project to try to, so part of the challenge with patch clamp and wholesale recordings is, 1, it's expensive, and 2, it takes like specialized expertise to be successful in doing that. But there are ways of automating the patching of cells. So we're working, because we like to do freely behaving stuff on some systems, who knows if they'll work or not, but on like single wholesale recordings and freely behaving animals that are fully automated. But who knows if it would work. But so some other people have done similar things, and I think it can scale to a much more affordable price.
Yeah, like you already alluded to, like autopatcher projects. So there's a couple, mostly algorithms that make it easier. The main challenge to dropping the price of a rig is not just the electronics, but also the manipulators that you need to move the pipette. There's a couple that I'm aware of that are trying to drop the price down, but at the end it's just really tricky mechanical engineering. It's kind of hard to make that go into the realm of the stuff we were talking about, because at the end of the day, if you need precision machined parts, it's just going to cost a certain amount of money. One thing that I thought was really cool that made a decent splash, I think about a year ago, was that someone used a Teensy microcontroller to implement like a dynamic clamp system where you react to the voltage that you record with some interesting control command to simulate the presence of ion channels that aren't really in the cell, which is something that's really hard to do even with current systems and expensive because it requires a lot of complicated electronics in the old school way of doing it. And this is literally like, how much is a Teensy? Like the $20 or something microcontroller. And they have an amazing website that explains how to do it. So this was one of those projects where the documentation was on point and someone can just take it and do really outrageous experiments with a $20 part. So there's some movement, but I think we're far away from having like a couple $100 patch rig that is actually usable.
Any other question? I think we are going to conclude now. We are only running 10 minutes late, so it was great. Thank you for the roundtable. Thank you for your work, for the whole community. It's great to see such things. And then it's time for, well, some closing words for the first day. So tomorrow, you know that, I guess a lot of you will participate to the hands-on we organize, and a lot of tools have been mentioned here. GitHub was referred as like a good tool to follow up and to have a platform to follow up about the coding, and you two guys will present things. And we have the Atlas also. Jérôme will demonstrate things. So I'm sure it will be a big success tomorrow, and people will be very interested. And I don't have really closing words, except that, it's my personal thought about like the whole day. First I was super excited. Just to tell you about the organization of this meeting, usually you do it on your own field, and you know, like 2/3 of the people you are invited and you are proposing. In this case, it was like clearly the opposite, because we wanted, as it was today, like to be very a broad discussion about a lot of different topics on open source. And I guess 2/3 of the speakers we invited, we didn't know them personally. So, and it was, I think you would agree with me, like we had very great talk, and I learned a lot, actually. I'm glad everything was video recorded, because we can like get back to all this information if you need to know more. And one thing that is missing, and it's not really our fault, but that was everybody was referring to, I guess, in all the session, is that we need somehow to have like what? Okay, well, I have to talk for 10 minutes, sorry guys. No, we can continue the discussion, but I guess like a key actor in the, if we want open source tools and open science to help science to grow faster, is the institution. And we kept referring to the fact that if we want to have something sustainable for hardware, for even a guideline for open publication, to give credits to like the tools that are designed, and to the people who are designing the tools that somehow don't get the credit they deserve, because they may not be the one publishing the big paper, because they spend their whole time designing the tools for you, for the community. And I guess this should be the role of the institution and the associated funding agencies. And we did try to contact some of the people. Everything is very new, I guess, like Science Europe and Planes was released very recently, but the institutions are not fully ready yet to apply all what they propose. And we did try to contact some institutions. Unfortunately, for different reasons, they either couldn't come, or they are not even ready to like really disclose what is their official policy. And we kind of understand that, because when you say it publicly, then people think it's not the truth, and things can change, so it has to be decided. And but it's really like I think what would make the success or not of like open science and open tools, because we need to have funding that are devoted from the institution to projects that promote some tools that have to be developed, perhaps with no scientific question, with just like a good idea of like how we could like create a tool that will be benefit for the community. And my project is to develop such a tool, and I need this amount of money. And so far, I don't know about the, I guess it depends on the country, but so far it doesn't really exist, at least in France, not of my knowledge. And you guys, I mean, I was trying to challenge you a bit on this, but it's not, I think, by chance that all these big successful initiatives are coming from institutions such as MIT, UCLA, Champalimaud. I mean, it's Allen Atlas is a great example. I mean, they put a lot of money. They decided to do it by their own or to support this, and then it was successful. So I guess on a more like governmental way, it should be supported through the National Funding Agency. I mean, it's one thing I'm thinking about, and I hope we'll do a second edition of this type of event, and definitely if we do it in a year or 2 years, we would definitely put a lot of effort to get some people from the institution that they give their position about it, and not just some words, but like concrete decision for this topic.
I have a very tiny addition to that point, which is that one of the reasons this was possible at all for us and generally for the US is that we have, I think, less pressure in our PhD to finish on some deadline. Right? So it's entirely okay for someone to take a year or two to develop something like that, as long as their PI is happy with it and there is some funding from some grant. So you have an environment where you, in some cases, are given too much rope and you spend 2 years doing something stupid. But if you don't have the ability to spend 1 or 2 years or something like that, it's not really possible to step away from your main project and do something like that properly. And this is how you end up with a bunch of dirty hacks that then die. So that's it's different, I think, for students in the EU where the timelines are a little more stringent.
I don't know if it's 10 minutes. I don't really know why they need 10 minutes. I mean, we can wait also outside. Well, I don't have like that much to say.
Go out and discuss.
Yeah, we can discuss outside. So thanks again. Please thank the speaker again. It was great. Thank you guys. I really enjoyed